for finding the interval of convergence for power series. Number one, use a ratio test, possibly the root test. And you can probably guess maybe where the root test would be a good one. You've got the power to a power, variable to a variable power. But anyway, an n to an n sort of scenario. But anyway, okay. Use a ratio test to find that interval. But then secondly, the one thing though you have to remember is to test the endpoints. Because the ratio test, it won't tell you about the endpoints because that's where you'll have equal to 1. And ratio test doesn't. Test each endpoint separately for convergence. And, you know, in our example, it came out harmonic series. It may be some other series. It may be a geometric series or something else. Just have to go with whatever it is. So that's the basics. That's the basics of intervals of convergence. At this point, I do like to mention a couple of things. Probably they're obvious things, but make sure you've got a couple of things on solving absolute value equations. You know, we saw the very basic one. X is absolute value of x is less than 1. That transitions into -1 to +1. What happens if I have the absolute value of 2x is less than 1? Or let's do it this way. Absolute value of 2x is less than 5. Well, that would go between +5 and -5, wouldn't it? And it would be 2x between +5 and -5. But to get it down to just what x is, what would I do there? Divide off the 2. The only thing is this is a 3-part inequality, and when I divide by 2, I've got to divide all 3 parts by 2. So it would be -5 halves is less than x is less than 5 halves. And so that would be the interval that would correspond to. So what do you got for this one? So if I have the absolute value of 3x minus 7 is less than 13, what x's am I talking about there? Well, that's going between -13 and +13, 3x minus 7. So just solve that. Add 7, all 3 parts. -6 is less than 3x, less than 20. Divide by 3, all 3 parts. And so that's -2 is less than x is less than 20/3. And so that, again, is part of the number line between -2 and +20/3. That's how you do those. One other one. What would you do if, this will happen, probably. What if I had a number like 1/3 in front of it? Yeah. If it's on the outside of it, and the same thing would go if it was added on the outside. If it's on the outside of it, I can, before I do the 3-part thing, I can clear out the the part that's outside of it. I mean, you can do it, I guess, when you move to the other, but it is typically easier to get rid of that. I can get rid of that now because of it being on the outside. So since it's on the outside, I can do that and then do the -12 to +12 thing. -17 to +7. Okay, I wanted to mention those beforehand. All right, so let's do another one. Got time? Okay, find the interval of convergence for sum n equals 1 to infinity, -1 to the n minus 1, x to the 2n minus 1 over 2n minus 1. What do I do first? First step is ratio test. Ratio test. And the ratio test is a limit n goes to infinity, a to the n plus 1 over a to the n. What does that give me here? Well, that's going to give me since I'm doing the absolute value, I'm not even going to try to mess with the negative alternating part of this, because that's going to go away because I'm doing the absolute value. So I'm just going to forego that and just do x for n plus 1, do 2n plus 1 minus 1 over 2n plus 1 minus 1. And then the divide a of n would be dividing by this, but that's going to mean reciprocal multiply, right? So let me just cut to the chase sort of here. Is everybody okay with that? See what I did there? Instead of writing it all out, we know some things that are going to happen there. Okay, so let's see what happens. That's going to give me the limit as n goes to infinity, x to the 2n plus 2 minus 1 over 2n plus 2 minus 1, and then 2n minus 1 over x to the 2n minus 1. Well, also kind of a deal that we always do is get the x's to one side of it and the n's to the other side of it. So here's what I'm going to do. Let's write this as 2n minus 1 over be 2n plus 1 times, and let's move that over. That would be x to the 2n plus 1 over x to the 2n minus 1. Let's see what happens there. Well, this winds up being, let's work on this a bit. What happens there? Well, something a little different happens there. The n stuff's going to go away, isn't it? because that's just x to the 2n times x to the first. Break those apart. And that's x to the 2n times x to the minus first. Yeah, the x to the 2n's go out. So really the only n part involved here is this. As n goes to infinity, if I divide by n there, what do I got? Well, that limit is going to be limit, n goes to infinity, 2 minus 1 over n over 2 plus 1 over n. That's going to be 2 over 2. And let's go ahead and talk about the x. What happens to the x here? Well, x to the minus 1 is on the bottom, x to the positive 1. So what does this simplify? What is that going to become? X squared. So this limit, 2, is going to be the absolute value of 2 over 2 times x squared, which is just the absolute value of x squared. Which, what does that tell me? Going back to the ratio test. Part 1 of the ratio test says if this limit is less than 1, this is the limit. The limit of this is x squared absolute value. Oh, which, by the way, I am talking real values here. So what would that mean here? Absolute values are not necessary here. When I've got x squared, and I'm talking real numbers, the absolute values are not necessary. So that's just x squared. So that limit is just x squared. Which, by the ratio test, says if this is less than 1, then the series is absolutely convergent. Okay. But what about it? That's a little different inequality than we have. We haven't talked about that inequality. We did some others, but we didn't talk about that one. X squared is less than 1. Where is x squared less than 1? About the same as before, isn't it? You square an x and want it less than 1, where does that happen? It's between 1 and negative 1 also. That's just where it happens, okay? X squared is less than 1 between negative 1 and positive 1 again. So we wind up with basically the same interval. However, the ratio test is inconclusive at where? X squared equals 1. So what do I have to do? I have to test separately then these solutions to this. Which x squared equals 1. Again, we're talking about the same values. X equals 1 and x equals negative 1. Right? I got to test those separately. So we come over here and do a little more work. So at x equals 1, what series do I have? I have the series x equals 1. So it's n equals 1 to infinity, negative 1 to the n minus 1. X is 1 now, so I've got 1 to the 2n minus 1 over 2n minus 1. What are you going to do with that? Well, 1 to the 2n minus 1 is just 1. All right? 1 to anything is 1. So this is just the series n equals 1 to infinity of negative 1 to the n minus 1 times 1 over 2n minus 1. So So this is where our knowledge of previous tests comes in handy. What should I do? What test you want to do? This will help you on your test. How would I test that series? What test? Well, it's an alternating series. Maybe alternating series test? Okay. Let's try the old AST. All right, for the AST, we're looking at what, B sub n? B sub n is just the positive part, or the part without the alternating signs. What does B sub n have to be? For our alternating series test, it has to be decreasing. And one point I'd like to make here, yeah, if you look at y equals 1 over 2x minus 1, and you can see that if you graph that, and you can see that's decreasing out there as in x goes to infinity. I'm okay. Just tell me, just show me the graph here. Let's see if that would explain it, because that was not an easy one to see. It doesn't compare really like we've done some of the others. If I can look at the graph of it and tell, that's not going to be good. Standard view. Yeah. This, it looks like this. Yeah, you can see as x goes out to infinity, yeah, this piece, that's decreasing. You can tell there. Okay. I mean, there's more direct or technical ways of doing it, but without getting to a lot of trouble there. You can look at the graph and tell it's decreasing. I'm okay with that. All right, then what's the second part? Second part is the limit of the b sub n's. It's got to equal 0. Well, that's going to be an easy one, isn't it? Divide by n. It's going to go to 0, isn't it? Which is what it needs to for alternating series test to give us a positive result there. Okay, so what happens? Decreasing, yes. This graph seems to indicate it's decreasing. The limit of b sub n's is 0, so what does that tell me? By alternating series test, this converges. So again, it's convergent at x equals 1 by alternating series test. But I still have one more to look at, and that is for -1 at x equals -1. I've got to look at the series n equals 1 to infinity, -1 to the n minus 1. Then I have to do -1 to the 2n minus 1 over 2n. Yeah, plug in. The other solution that we didn't know about was when x was -1. Plug that in. Well, what can I do with these? Aren't those the same base, so I can combine their exponents? So what does that give me? -1, 3n, minus 1 would be minus 2. Tell anything about that? That's going to do what? N equals 1, we'll have 3 minus 2, which is 1. If I do n equals 2, I'll have 6 minus 2, which is 4. When I have n equals 3, I'll have 9 minus 2, which is 7. That's going to alternate. As far as those powers between odd and even, that's just going to be alternating. This is alternating signs, just like that, isn't it? It's the same series. It just has a little different power of 1. It's the same. Okay. Same as the other. It's alternating, convergent by converges by alternating series test. Don't have to go through all that again, okay? So what does this tell me? Well, from the ratio test, I got it converges for -1 to +1. Then by the endpoint test here, it also converges for x equals 1 and x equals -1. So by step 1, it converges between -1 and +1. And then by checking the endpoints, I got it also converging at the +1 and -1. So where is this convergent? Everything between -1 and +1. I can write it that way, or I could write it, I could go ahead and write that one this way, couldn't I? And again, this little notation too, because of the way it's made here, also would give me, what would you say the radius of convergence is? It's going to be 1. Radius of convergence is 1.